Hi everyone, and welcome back to Minds and Machines with me, Dr. Josh Redstone. Today what we'll be doing is continuing to talk about passing the Turing test. Last time we talked a little bit about the Turing test as an empirical test, and we looked at, very briefly mind you, whether a chatbot like Elisa, one of the earliest chatbots, passes the test. I don't think we can say Elisa passed the test. But in any case, that was meant to sort of illustrate thinking of Turing's test as an empirical test. Today we're going to be thinking about it more along the lines of a thought experiment. And to that end, we'll be taking a look at John Searle's Chinese room thought experiment, which, depending on your intuitions and which way this thought experiment gets your intuitions pumping, highlights a potential problem with the Turing test. So let's get into it now. Now, of course, a big theme in this class, probably the main theme of this class, is that the mind is like a machine, or that the mind is a type of machine. The mind is a computing machine, a computer, and cognition or thinking is just computation. So that's a big theme in this class and in mechanistic philosophy in general, which we've read a lot of in this class. And of course, more recently, we can see things start to come together. Little antecedents of functionalism and computation and things like that that we saw when we read the more historical works that we've taken a look at in this class have started to be put together by thinkers like Putnam and Turing and those figures. So this is a massive theme, but is there a problem with it? Well, maybe. So the mind might be a computer. The mind might be just a natural computing machine, right? A computer that was designed, if you like, by nature, by evolution. Now, if this is true, then what minds do is not altogether any different than what computers do, right? It's all information processing. Moreover, it's rule-governed information processing. If this is correct, if this computational representational theory of mind is correct, then the mind is just a Turing machine, right? And information is represented, well, symbolically, probably. When we're talking about Turing machines, we're talking about symbols on a tape. But when we're talking about our brain and the physical realization of our mind, we're talking about neuronal firing patterns and whatnot. But if this is true, computation is just rule-governed information processing. Usually this information is understood to be represented symbolically, although there are some non-symbolic ways of computing things. This is the whole motivation behind artificial neural networks, which we haven't really talked about a lot in this class. But if you take another class with me in future, you'll probably learn more about those then. If this computational representational theory of mind is correct, if the physical symbol system hypothesis, which we talked about in one of our earlier lectures, is correct, then cognition is just computation, and cognition, computation, both are rule-governed information processing. And that's all there is to it. But the philosopher John Searle has offered a pretty powerful objection to the notion that manipulating symbols and symbol structures according to rules or algorithms is sufficient to constitute intelligent behavior. And to make this case, he has the readers undertake the Chinese room thought experiment. So that's what we're going to do. We're going to look at what this thought experiment is, what we are being asked to imagine, and what concepts is this trying to get us to think about? What intuitions is this thought experiment meant to get pumping, right? We'll talk about that now. So John Searle presents this thought experiment in a 1980 paper, which is your required reading for this lecture. The paper is entitled Minds, Brains, and Programs, and he talks about some of the problems that he sees with the whole enterprise of understanding cognition as symbolic computation. Basically, the kind of thing Searle is raising an issue with is the kinds of scripts you see in action in, for example, Elisa's program, or perhaps more relevant here, one of Shank's computer program. A researcher named Shank in the 1970s would construct these computer programs, which he called scripts, that consisted of a number of condition action rules or production rules. If condition X obtains, then perform action Y, rules like this, and background knowledge. And he would try to create these scripts that could answer questions about particular scenarios that humans face all the time. One of these famous scripts, which Searle actually talks about in this paper, is Shank's restaurant script. So we have a script that governs our program's behavior, how it answers questions, and we have some background knowledge about restaurants. And what this program was meant to do is answer questions which it doesn't explicitly have any knowledge about the answers to, and it has to use its background knowledge and its production rules to come up with the correct answers. So we have this restaurant script, right? And the restaurant script has all this background information about what people typically do in restaurants and these production rules. And we're gonna give a scenario, a restaurant-themed scenario, to our computer program. We'll tell the computer program a story like a man went into the restaurant and signaled the server. He orders a hamburger. A little while later, the man leaves the restaurant, pays his bill, and leaves a big tip for the server. So that's the story. Now, what the restaurant script has to do is answer questions about that. For example, we could ask, did the man eat the hamburger? You know the answer to that, probably without thinking about it. Well, we weren't told the man ate the hamburger, but he sat in the restaurant for a little bit. He left, he paid his bill, and he left a big tip. So I think it would be reasonable to surmise that not only did he eat the hamburger, but he thoroughly enjoyed his hamburger as well. Now, the idea behind Shank's programs was that it was supposed to be able to answer the same questions, the same kinds of questions, right, that I just put to you. We give the program this scenario, and the program has to work out whether the man ate the hamburger, right? And Shank's programs work reasonably well for these limited domains, but they don't generalize very well because we run into problems like the frame problem and whatnot, where we don't quite know how to work out or how to get the computer program to work out what knowledge, what beliefs are relevant for answering these questions such that this computer program could run for a very, very long time and basically become computationally intractable. So these are the kinds of programs that Searle is trying to raise an issue with. These kind of restaurant script kind of programs, production rules, if-then rules. All the AI at the time, pretty much, there was a little bit of neural network research going on, but not a whole lot at this time because we didn't know how to train neural networks. So much of the AI that people were saying, in a few years' time, back in the 1950s, they were saying in a few years' time, we'll have strong AI, we'll have general artificial intelligence. And Searle's saying, look, it's been a while and we still don't have that. And, we're using the symbolic AI sort of paradigm here, but it's not strong AI like we thought it would be. Why is that? Well, he's going to show or try to show that it's because these kinds of programs just do not have what is necessary for intelligent behavior. I mean, think back to all the way back to that lecture, What is the Mind, when we talked briefly about the physical symbol system hypothesis. Recall that Newell and Simon said that a physical symbol system has the necessary and sufficient means for general intelligent action. Remember, that's a strong claim, right? I'll post a card to that lecture up here if you want to go back and review it. Basically, Searle is saying with this thought experiment, no, not at all. These physical symbol systems do not have the necessary or sufficient conditions to count as intelligent. And as we'll see, Searle's thought experiment, thus the title of this lecture, is also a powerful argument against the utility of the Turing test. So, this is kind of what Searle's doing. He's trying to use this thought experiment to object to the idea that symbolic information processing is necessary or sufficient for intelligence. If he's right about that, it also means that the Turing test is not going to be a good test of machine intelligence, whether we're talking about using it empirically or as a thought experiment. So that's the background that you'll want to know heading into thinking about this thought experiment. Now let's look at the thought experiment itself. All right, the Chinese room thought experiment. What is that all about? Well, we're going to have to use our imaginations for this one, okay? So let us all imagine a room, and there's a person inside this room. She's sitting in there, and the important thing about this person is that she's a native speaker of English, but she does not speak or read or understand any Chinese at all. No Mandarin, no Cantonese, nothing. She only speaks English. She only reads English. She only writes English. Now in this room, there's a door, and there's like a slot in the door where we can pass sheets of paper in and out of the room. So sheets of paper come into the room from the people outside of the room. The people outside of the room all understand Chinese. Let's say they're all native speakers of Mandarin Chinese, just because Searle doesn't specify, but Mandarin is, I believe, the language with the most speakers in China. So let's say the people outside the room, they are speaking Mandarin, they read Mandarin, they write Mandarin, they understand Mandarin, but they don't speak any English, okay? So we have our Mandarin speakers outside of the room and our English speaker inside of the room. And the Mandarin speakers outside can pass messages on sheets of paper in this little slot in the room. So they pass their messages in, and the person in the room who doesn't speak Chinese, her job is to respond to the messages that she receives. So maybe the people outside the room write a message, and it's in Chinese, and it says, "Hello, how are you?" Of course, you'll just have to imagine it's in Chinese. I don't speak Mandarin Chinese, but just remember, we're using our imaginations here. So the person in the room gets this message, and it's just all these Chinese characters. She doesn't understand what it says, but she has a rule book with her. The rule book is, if you like, a bit like a computer program here. So she's got this rule book, and the rule book allows her to always give an appropriate response to the message she receives, even though she can't read the messages. So she gets a piece of paper and she says there's this symbol, this symbol, this symbol, and this symbol. So she looks it up in her rule book. And her rule book, by the way, has all the rules have the structure of condition action rules. If X, do Y. So if this string of symbols, then reply with this string of symbols. She doesn't know what these symbols mean, but it said the rule book, which is written in English, says, if you get this set of symbols, hello, how are you? Respond with this set, which means, I am well, how are you? Again, the person in the room doesn't know what it means, but she just says, if these symbols, then these symbols. She sees that in her rule book, writes down the symbols on the piece of paper, passes that back out to the native speakers of Mandarin who are outside of the room. Now, to the native speakers of Mandarin outside of the room, it seems as though whoever, or indeed whatever, is in the room can understand Chinese. In other words, it looks to the people outside of the room that the person in the room understands Mandarin. She is a fluent speaker of Mandarin. But of course, according to the conditions of the thought experiment that Searle lays out, this person does not read or write or understand any Mandarin. So she is successfully responding to messages just by following her rules in her rule book, her program. But there is no understanding there. The person in the room does not, Searle argues, understand Chinese at all, even though she's able to successfully respond to the messages she's receiving. She is just, Searle argues, blindly manipulating these inputs and transforming them to outputs according to the rules in her book, but she doesn't understand the meaning of the symbols themselves. Searle says the meaning of the symbols is not intrinsic to this system. It is parasitic upon the system, and that's a problem for Searle. So What Searle is trying to show here is that it is possible for there to be syntactic, that is rule governed, symbol manipulation or information processing with no intelligence or understanding being present whatsoever. The person who is following the rules does not grasp the meaning of the symbols. She is blind to the semantics of the system, and she only manipulates things according to rules, syntactically. So Searle is trying to say, again, that here semantics is parasitic to the syntax. Meaning is parasitic upon the rules that are being followed. They're not, or rather to the symbols being used. The meaning is not intrinsic to the symbols. So basically, this is just a complicated way of saying, or trying to elicit this feeling in you that why, yes, the person in the room is like a computer program, just following rules and successfully transforming inputs into the right kind of outputs without knowing anything about what it's doing. It's just a computer program. It's not really smart. It doesn't know anything. It doesn't understand something. It's just a dumb mechanical process. And that is what Searle is trying to show, is that this is a problem with symbolic cognition, that whole paradigm, and especially with the physical symbol system hypothesis, with the idea of the Turing machine, the idea of the Turing test. He's trying to point out that there is a problem here, and that is that syntax is not semantics. The syntax, the symbols and so forth, do not equal meaning or understanding or intelligence. So that is what Searle is trying to show here. Yeah, so basically, just to summarize once again, before we go on to some of the objections and replies, the person in the room is analogous to a computer running a program. The program is the rule book, and the rules in the rule book have the same structure as the kinds of computer programs did and still do to this day, like Shank's restaurant program or ELISA or a Turing machine, anything like that. It's like we can understand the whole thing in terms of symbolic condition action rules, right? So the person in the room doesn't understand any of this Chinese, none of those symbols. She doesn't understand any of it, but she communicates with the people outside of the room. The person in the room, even though she doesn't understand Chinese, seems to pass the Turing test to the people outside of the room who are native speakers of Mandarin and who are convinced that the person in the room understands the messages that are being sent into the room. So if Searle is right and there really isn't any genuine understanding going on in the Chinese room, then this is also a pretty big argument against the Turing test as well. So that's something that is, wow. And of course, Searle is going to say this about computers generally, right? Computers are not really intelligent. They don't really understand things. So physical symbol systems have the necessary and sufficient means for general intelligent action? I don't think so, says Searle with this thought experiment. So that's what it's all about. So, now before we go on, I'll just really quickly recap the Turing test one more time, and then we're going to look at a couple of objections and replies to Searle's Chinese room thought experiment. So just to recap and reiterate a little bit about the Turing test and why this is relevant to the test, remember that in Alan Turing's original formulation of the imitation game, he has a man and a woman and an interrogator. They're all in separate rooms. The man's job is to convince the interrogator that he is actually the woman, and the woman's job is to ask or to answer truthfully to the interrogator's questions. And Turing thinks we need to use a scenario like this in place of the question, can machines think? And we replace one of the players, A or B, with a computer and see how well it does at playing the game. And of course, in later iterations of the test, Turing limits this to just two players, or really one player and one interrogator. The interrogator's job is still to ask questions. The player answers them, and the player can be a human or a machine. And if the interrogator cannot tell the difference, then the machine, if it is a machine, passes the test. So you can see the similarity between these two scenarios, and that is, I think, very intentional on the part of Searle, is to come up with a scenario that is quite a bit like the Turing test, where he can make a reasonably good case that what the thing playing the test is doing cannot count as thinking, because there is no understanding. The person in the room does not understand Chinese, even though it seems like she's carrying on a conversation in Chinese just by looking up the correct rules in the rule book and answering appropriately. Now, of course, this is just a thought experiment, right? What Searle is putting forward here is a thought experiment in that it's meant to test our intuitions. It's meant to test our concepts and our beliefs about things. Daniel Dennett calls thought experiments intuition pumps, and I really like that term. That's how I use that's why I use that term as well. I borrowed that from Dennett because I think it really nicely captures what thought experiments are meant to do. They're meant to get us to clarify our concepts about the things we're asking questions about. So this thought experiment is meant to get our intuitions pumping and our concepts clear about what thinking is. That's what this is all about. And of course, Searle is also responding to the claims of the symbolic paradigm, namely the physical symbol system hypothesis, which we covered in my lecture, What is the Mind? So basically, as with any thought experiment, when it comes to the Chinese room, some of you are probably going to agree with Searle. Yes, the agent in the room is not showing understanding of Chinese, at least. So maybe you'll agree with him that there's more to intelligence or understanding than just computation, than just the rule-governed manipulation of symbol structures which represent information, right? But if you disagree with Searle, maybe you'll sympathize with one of these replies to the Chinese room thought experiment. Let's take a look at these two replies. The first is the systems reply, and the second is known as the robot reply. So yeah, let's have a look at both of those now. The systems reply. Well, this nicely highlights that, one of the issues with the Chinese room, if you have an issue with it, is where Searle is trying to say the understanding actually is. And the systems reply says basically that the person in the room does not understand Chinese, but the whole system does. The whole room, inputs, outputs, rulebook, and the person, the whole thing together can be said to understand Chinese. So the person in the room, she doesn't understand Chinese. She is behaving intelligently, though. I don't think anyone would dispute that. She's able to find the string of symbols she's received on her message through the door in her rule book and to look up the appropriate response. So she is behaving intelligently in some sense. And maybe we can analyze understanding Chinese or understanding more generally in terms of these more basic forms of understanding, which the person in the room arguably has. So maybe Searle is not looking in the right place for intelligence. The person in the room, as I said a moment ago, might not understand Chinese, but perhaps the whole system can be said to understand Chinese, right? And if your intuitions do happen to align with this response, then maybe you are also one of those people that's perfectly comfortable with the idea of cognition just being computation, right? So just to summarize the systems reply, yeah, the person in the room doesn't understand Chinese, but she certainly demonstrates some kind of intelligence and understanding. And understanding Chinese may be a matter of building off of these more fundamental types of understanding, more rudimentary types of understanding and intelligence. I mean, understanding and speaking a language is more complicated than, knowing how to move your mouth to make certain phonemes like ah or oo or puh, right? You don't get to speak a language until you can do this, at least, right? That's why babies babble before they speak, right? So in the same way, the person in the room and the room itself and the rule book are all contributing to the overall understanding of the entire system, the entire system's understanding of Chinese, right? So that is the system's reply. What about the robot reply? Well, maybe we grant that the person in the room doesn't understand Chinese, or even the whole room doesn't understand Chinese. But it's not because manipulating syntactical structures according to rules is insufficient for cognition or understanding or intelligence. It's because embodied agents like humans are the kinds of agents that understand Chinese or English. Not weird disembodied systems made up of rule books and people in rooms that we pass messages in and out of, right? This is to say that understanding Chinese, speaking Chinese, or indeed any other language involves interacting with other speakers of that language who all have minds that can do the same sort of thing that yours can do. Not only that, we're doing that in a society where everybody's using the same words and signs in a similar enough way in reference to things in the world or to things, like their thoughts and their mind, all in a consistent enough way that we can all understand each other and get along with one another and make sense of each other and the world itself, right? So maybe, the robot reply goes, if we gave the Chinese room a robot body with the right kinds of sensors and effectors, the right kinds of capabilities for action, for being in the world, it sounds a little Heideggerian, but if we made a little Heideggerian sort of robot that could be in the world, and we put the Chinese room in the robot could interact with other Chinese speakers in a Chinese language context, and after a while would learn to speak Chinese, and then perhaps we could say that the robot understands Chinese, right? Now, even if we did this, Searle would probably still say that this agent, our robot, would not understand Chinese at all. It wouldn't have genuine understanding because it's still a physical symbol system. Searle is trying to show that physical symbol systems do not have the necessary and sufficient means for general intelligent action. So, I don't know, what do you all think? I'm curious to hear from you, definitely leave a comment or tell me what you think in the discussion forums on See You Learn if you're a student of mine. Do you think that the person in the Chinese room has understanding or intelligence, or does she not? Or are you more sympathetic with one of the replies to Searle's position? If you like the system's reply, then maybe the person in the room doesn't understand Chinese, but the whole system does. Or maybe the whole system could understand Chinese and be said to behave intelligently if it had the right kind of body, sense organs, and could interact with the world and with other speaking agents in the right kind of way. Then maybe it would develop some kind of understanding of Chinese. I'd love to hear what you all think, so definitely let me know how this thought experiment got your intuitions pumping in the comment section or on See You Learn. Whether you agree with Searle or not, the Chinese room argument does illustrate a pretty pressing problem for philosophers and cognitive scientists, and this is called the symbol grounding problem. The problem is, how do symbols become meaningful, right? If cognition is information processing, that information has to be represented somehow. And usually we do this symbolically with physical patterns, switches being on and off, circuits being on and off, which represent the value of true and false, or 1 and 0, right? So that's what those symbols mean. How do they get that meaning, or how do they become meaningful, though? It's a bit like this. If you imagined, if you want to get a sense of the symbol grounding problem and where symbols get their meaning, just trying to imagine learning a language by looking up words in a dictionary. But you don't really speak the language, so you need to look up a word, and it says this means, this other word. So you go and look up that other word. But then it just refers you back to the original word you were looking up. The symbols are not grounded in any way. We need a way to ground our symbols to understand where their meaning comes from. This is what Searle's kind of worried about here. This is why he says that the semantics, or the meaning of the symbols, is parasitic upon the syntax or signs or the symbols themselves. They're not intrinsic to the symbols themselves. And it seems like Searle thinks that for there to be understanding, the meaning needs to be intrinsic to the symbols, although I'm not really sure that that has to be the case, because I'm a little bit skeptical of what Searle is laying down here, if I'm being perfectly honest. Anyway, the symbol grounding problem is just something that you should be aware of. If you continue studying philosophy of mind and AI, you will doubtlessly run into the symbol grounding problem again. We don't have time to deal with it today, but it's related to a similar problem, the problem of intentionality. You remember intentionality is this ability for thoughts or mental states to be about things, or for mental states to have content. And according to Franz Brentano, intentionality is the mark of the mental. But if we're to explain how mental states have content, we kind of need to address the symbol grounding problem, if indeed our minds are symbolic computers like Turing machines. Also, the people who do share the intuitions that drive Searle's Chinese room argument have a couple of options. I don't follow this very closely because I'm perfectly happy being a computationalist, really, for the most part. But if you're not happy with computationalism, if you think that the Chinese room does highlight a problem with the physical symbol system hypothesis, if you think that it does show that the physical symbol systems do not have the necessary and sufficient means for general intelligent action, you have a couple of options. What you can do is abandon the idea altogether that cognition is information processing. That's one option, and perhaps some of you will be amenable to that. This is certainly where I think a lot of dualists, and especially substance dualists, and Mysterians might be sympathetic to this option, right? But we don't want to we don't want to abandon this idea just yet, because this is minds and machines after all. So maybe another possibility is that you can look for ways of information processing that are not symbolic. And there are a few of those out there, of course. There are artificial neural networks. Those are not symbolic in the traditional sense. And there's dynamic systems theory, which looks at minds in terms of dynamic systems, where one change to the system affects every other variable in the system. Dynamic systems is kind of rooted in cybernetics, interestingly enough. And there are hybrid systems too. Artificial cognitive systems that incorporate both symbolic and non-symbolic elements to them, which we don't have time to look at in this class. But if you ever have the chance to take a class like Introduction to Cognitive Science with me in the future, guaranteed we will talk about this stuff in a class like that. So keep your eyes out for that if you're interested in the future about learning anything beyond the symbolic paradigm, learning about things beyond the symbolic paradigm. There are many opportunities to do so in university, whether you take those classes from me or from somebody else. So, yeah. All right. Well, okay, that was another quick one. I know I was talking very, very quickly there. I'm just trying to get caught up because we are really getting close to the end of the term, and I've got to get these lectures out there. Luckily, you're not being tested on any of this material, but all of the material in the last few lectures will probably come in pretty handy on all of your final papers, which, as you know, are due at the end of the exam period. on April 27th. So I'm shortening all of the remaining lectures, but I'm still going to get them all done. You can watch them at your convenience, or if you notice a lecture that might have something particularly useful when it comes to your final paper, watch that one first and then go and watch the other ones. But anyway, that's it for today. I encourage all of you to get in touch with me if you have any questions about the Chinese room thought experiment, because, you know, it is a thought experiment. It can be tricky to think about if you're not used to doing thought experiments. And next time, we're going to take a look at our last bit of reading. We're going to read Daniel Dennett's 1978 paper, Why You Can't Make a Computer That Feels Pain. So we'll take a look at that over the next couple of lectures. Then I'll produce a couple of brief special topics lectures based on your votes. And then we will wrap up the class and we'll be all finished for the term. All right, so that's it. We'll see you all very soon for our next lecture. In the meantime, take care of yourselves. Let me know if you have any questions about the material or any of the assignments, and I'll see you all next time. All right, bye for now, everyone.